When you look at a robot, it's basically just a hunk of metal and wires, right? So how does it learn to see, to feel, and to actually interact with the world around it? What's the secret that turns it from an inanimate object into a machine that can think and act? Well, we're about to dive in.
So let's start with a question that sounds super simple, but is actually incredibly complex. How does a robot know how to pick up an object? I mean, for us, it's totally automatic. We see something, we reach for it, we grab it. We don't even think about it. But for a machine, that whole sequence, searching, recognizing, grasping, it's like a technological symphony.
And probably the easiest way to wrap your head around all this is to just compare it to our own bodies. A robot's senses, its way of seeing and feeling, are its sensors. And its hands, well, those are what we call end effectors. Senses and hands. That's really the whole framework right there.
Okay, so let's tackle the senses first. Because before a robot can do anything, it has to perceive what's going on. It has to collect information about itself and its environment, just like we do.
So what exactly is a robotic sensor? At its core, it's a device that's constantly gathering information about the robot itself, about its surroundings, and then it shoots all that data over to the robot's controller, which is basically its brain. You can almost think of sensors as the robot's nervous system.
But here's the thing. Not all sensors are created equal. For a sensor to be really good, it needs to nail three things: accuracy, speed, and reliability. Accuracy is a must, because the robot has to know exactly where something is. Speed is crucial. In a factory, milliseconds matter. And of course, reliability. These things have to work flawlessly, millions and millions of times.
All right, so how do these sensors actually work in the real world? Let's look at a few of the key types that let robots see and feel what's around them.
First up, we've got proximity sensors. These are kind of like a robot's sixth sense. They can tell when an object is nearby without ever making physical contact, and that is absolutely crucial for avoiding collisions and just generally keeping the whole operation running safely.
Then you have range sensors. These are basically the robot's high-tech tape measures. They use clever techniques like triangulation to figure out the precise distance to an object. This is how a robot builds a map of its workspace and navigates through a chaotic environment without bumping into things. But honestly, the real game changer is machine vision. This is literally how robots see. We're talking about the ability to pick one specific part out of a giant bin of thousands, or to spot a tiny defect on a circuit board that no human eye would ever catch. It's their most powerful sense by far. Okay, so the robot has used its sensors to see an object and figure out where it is. Now what? It needs to actually interact with it, to pick it up. And that brings us to the robot's hand.
Now, the fancy technical term is end effector, which is just any tool you stick on the end of a robot's arm. But the one we see most often, and the one we're going to focus on, is the gripper. Its whole job is to grasp and hold objects, to act like a hand.
But here's where robots are really different from us. Our hands are amazing. We can do almost anything with them. Robot grippers, on the other hand, are specialists. There's a different tool designed for almost every single task imaginable. Let's break down the three main types. First, you have mechanical grippers. Think of these like simple claws or fingers. They're great all-rounders for a lot of general tasks. Then, you've got vacuum grippers, which use suction. These are perfect for lifting flat, smooth things like a sheet of glass or a cardboard box. And finally, magnetic grippers, which are, you guessed it, for picking up metal parts. Each one is a master of its own little domain.
And it's this kind of specialization that really pushes the technology forward. As the tools get smarter and more efficient, the robots themselves get a whole lot smarter too.
Let me show you exactly what I'm talking about. We're going to compare two grippers, one from way back in 1983 and another from 2001. The difference is pretty staggering. So back in 1983, a pretty standard gripper had an efficiency of about 2.4 joules per kilogram. Now, what does that mean? It's just a simple way of saying how much gripping force you get for the weight of the gripper itself. And at the time, 2.4 was pretty solid.
Okay, now let's fast forward to 2001. A new generation of gripper comes out, and it clocks in at 8.1 joules per kilogram. That is more than 3 times the efficiency in less than 2 decades. A massive leap.
So who cares, right? What does that actually mean for the real world? Well, it means the grippers got a lot stronger while also getting lighter. And that allows the entire robot to move faster, be more precise, and take on tasks that were impossible before. It was a total game changer for manufacturing.
So we started this whole thing by comparing robots to people with their senses and their hands. And as this technology just keeps getting better and better, that line between machine and human gets just a little bit blurrier. Which of course leads us to the really big question. As these senses and hands become even more human-like, what on earth will they be capable of next?